Welcome, everyone, to today's Explainer. I am absolutely thrilled to have you here as we unpack some truly groundbreaking medical research. We're going to explore a topic that feels almost like science fiction, yet it's happening right now in laboratories and clinical trials all around the world. We're looking at a completely paradigm-shifting approach to one of the globe's most persistent health crises, diabetes. Let's look closely at the data to build a clear understanding of exactly how this works.
Okay, let's dive into this. What if the medical waste from birth could cure a lifelong disease? It sounds unbelievable, right? But the staggering global rise of diabetes has actually pushed scientists to look for answers in the most unexpected places. For decades, researchers have been searching for a way to not just manage diabetes, but to actually cure it. And what the latest scientific literature is showing us is that the key might just be a classic trash-to-treasure story. Something routinely discarded in delivery rooms across the globe could literally hold the power to reverse a condition that affects hundreds of millions of people.
Section 1. The Diabetes Epidemic.
To really understand the magnitude of this crisis, we first need to look at how a healthy body manages sugar. It all comes down to specialized cells in your pancreas called beta cells. Think of these beta cells as microscopic, highly intelligent sensors. Step 1. They constantly monitor your blood glucose levels. Step 2. The moment sugar enters your system, they release the exact right amount of insulin. And Step 3. This flawlessly maintains your biological balance, keeping your glucose within a safe physiological range. It's a brilliant, self-regulating loop.
But here is where things go tragically wrong. In type 1 diabetes, this brilliant system completely breaks down. Type 1 is an autoimmune disease, and for reasons we're actually still trying to fully grasp, the body's own immune system turns against itself and destroys those vital insulin-producing beta cells. Once those cells are gone, the patient completely loses the ability to control their blood sugar, leading to dangerous hyperglycemia. They are suddenly left without their natural biological regulators.
Section 2. Limits of traditional methods.
So how do we handle this right now? Currently, we fight this disease with exogenous insulin. That's insulin injected into the body. And while it absolutely keeps patients alive, it requires a grueling, lifelong dependency. We're talking daily injections or pumps, constant monitoring, and it carries the risk of severe side effects if the dosage isn't perfectly calculated. Now compare that to endogenous insulin, the insulin naturally and safely produced by your own beta cells. Exogenous therapies are a crucial lifeline for sure, but they are no substitute for the perfection of endogenous production.
So you might be wondering, well, why not just give the patient a new pancreas with healthy beta cells? It's a fair question. The reality is, pancreas transplants are considered major, incredibly high-risk surgeries. They require agonizingly long recovery times, and actually, they're often only performed when a patient is already in end-stage renal failure, meaning the procedure is combined with a kidney transplant. But most crucially, there's just an extreme shortage of organ donors. It's a rare, dangerous option that simply cannot scale to meet the needs of millions. We absolutely need a better way.
Section 3. The stem cells search.
Now, what's really interesting about the research here is that the search leaves us with three main contenders. First up, embryonic stem cells, or ESCs. They have nearly unlimited plasticity and can easily become beta cells, but their clinical use is heavily restricted due to well-documented ethical and regulatory concerns. Second, we have induced pluripotent stem cells, or iPSCs. These have super high potential, but the source data shows they carry a really dangerous risk of forming tumors due to inherited somatic mutations. And that leaves us with the third option, mesenchymal stem cells, or MSCs. As we'll see, they have the incredible ability to restore insulin secretion without the regulatory hurdles or those high tumor risks.
And get this isn't just some theory in a petri dish. Think about this number for a second. Greater than 60. Over 60 clinical trials documented on clinicaltrials.gov have actively explored using MSCs for treating both type 1 and type 2 diabetes. This is active, rigorous, promising science happening right now, which essentially proves that MSCs are the clear front-runner in the race for a cure.
Section 4. Why do MSCs excel?
So, what is their secret? MSCs do two incredibly vital things depending on the type of diabetes. For type 1, they actually mediate immune tolerance. Basically, they act like peacekeepers, calming the immune system down to delay or even entirely halt the destruction of the remaining beta cells. For type 2 diabetes, they utilize their anti-inflammatory features to reduce the chronic, low-grade inflammation that causes insulin resistance in the first place. Even in cases where they don't offer a 100% cure overnight, studies remarkably show they can partially improve blood sugar control by tackling the absolute root causes of the disease.
Now, of course, for these cells to be used safely in humans, they have to meet incredibly rigorous standards. The International Society for Cell and Gene Therapy, the ISCT, mandates that true clinical-grade MSCs must prove they can differentiate into bone, cartilage, and fat. They have to proliferate highly in a lab setting, and they must express very specific surface markers, CD73, CD90, and CD105. Plus, their cultivation requires the absolute strictest infection and disease control. It is a highly, highly precise science.
So the crucial point is, where do we actually get them? Traditionally, MSCs are extracted from bone marrow or adipose tissue, which is just body fat. While that's effective, getting them requires painful, invasive surgical procedures for the donor. This major bottleneck led researchers to ask a vital question. Is there an alternative extraction method? Like, is there a painless, abundant source of these supercells just waiting to be tapped?
Section 5. The umbilical cord miracle.
Our source material highlights a really profound realization here. It notes that umbilical cord blood and tissue, which, let's be honest, are widely considered medical waste and are routinely discarded, offer a completely non-invasive collection method. Just think about that for a second. What is literally thrown into the biohazard bin in delivery rooms every single day is actually one of the most precious, potent biological resources on the entire planet.
And this brilliantly illustrates why umbilical cord MSCs are changing everything. Let's run through these specific superpowers. First, they offer profound immunomodulation, calming down aggressive T cells, B cells, dendritic cells, and natural killer cells. Second, they possess an incredibly high regenerative capacity. Crucially, they are non-oncogenic, meaning they just don't carry the dangerous tumor risks associated with iPSCs. And, as we just discussed, collecting them is completely non-invasive to both the mother and the baby. They are overwhelmingly safer and infinitely more practical. And here is the ultimate payoff. Under specific, controlled laboratory conditions, these umbilical cord MSCs can be induced to differentiate directly into ideal insulin-producing beta cells. They can literally replace what the diabetic body has lost. This means we finally have a pathway to a safe replacement therapy that doesn't rely on controversial embryonic cells, doesn't risk dangerous genetic mutations, and doesn't require waiting around on a tragic organ donor list. It's a real game changer.
Which leaves us with this really powerful, provocative thought to conclude our explainer. Are the cures to our most chronic, devastating diseases quite literally born alongside us? The data strongly suggests that the key to healing has been hiding right in plain sight, discarded at the very beginning of life. It's a profound shift in how we view medicine, how we view waste, and the incredible regenerative power of the human body. I really hope this look at the research has inspired you and sparked your curiosity to keep following this incredible medical frontier. Keep learning, keep questioning, and thank you so much for joining me on this deep dive.